this video, we will be flushing the cooling system in this 2001 Ford F-150. For this service, I have installed rhino ramps on the front tires. I have also installed safety stands in case the rhino ramps fail. I have wheel chocks behind the rear tires, and I have set the parking brake. Through the driver's side door, we first need to pop the hood to gain access to the engine bay. Taking a look in the engine bay, we need to locate the radiator overflow reservoir. This is located on the driver's side portion of the engine towards the front. If and only if the engine is completely cool, remove the radiator expansion tank cap. Next, we need to locate the drain fitting on the radiator. This is located on the passenger side of the engine, and you can gain access to it from underneath the vehicle. From underneath, near the wheel well, we can take a look up towards the radiator. We have a drain with a spigot. We need to connect a hose to the spigot so that when we open the drain plug, we can direct the flow of coolant into our collection container. That hose will then be placed into a collection container, something large enough to hold multiple gallons of fluid. We can use a 3/4 inch socket on a ratchet to open our drain. We can let the cooling system drain completely out. While it's draining, we can locate the block drain plug. This is located underneath the vehicle, inward of the driver's side tire by the oil pan. I will apply some Amsoil's metal protector to the plug and let it sit for a while. While we are letting the Amsoil's metal protector soak in and the coolant drain from the radiator, I wanted to take this opportunity to clean the coolant reservoir. And to do that, we first need to remove the plastic shroud that covers the front of the engine bay. Using a Phillips head screwdriver, we can release each of the plastic retaining clips. The crank for the spare tire needs to be removed before we can remove that plastic shroud. Next, we need to locate the bolts that are holding in the reservoir. One is located towards the front of the engine. The other is located on the side. Using a 5/16 socket, we can loosen that up. The one on the side is a little bit difficult to get to, a little bit difficult to see, and a little bit difficult to maneuver the ratchet around to remove the screw. To give us a little bit better mobility, we need to disconnect the coolant hose. You might have to work at it a little bit since it's been on there a long time. Just be careful you don't crack the reservoir. And remove the air filter housing. We also have a lower coolant hose on that reservoir that needs to be removed, and then we can slowly work it out of its current location. Shifting our attention back to the block plug, we're going to loosen it and remove it, which will allow additional coolant inside the block to drain out. The drain plug in the block is extremely difficult to remove. The only way I was able to get the required leverage to remove it was to connect a bunch of extensions together on a ratchet. And the end, I had a 5/16 hex head socket end. This allowed me to remove the plug. Make sure you have a collection container below this plug as you remove it. While that's draining, we'll jump back into the engine and identify the lower radiator hose that we previously removed from the reservoir. This is the location that I will be introducing hose water to flush out any residual contaminants or debris in the system. This will then be expelled into our collection buckets. We want to do this until the water coming out is clean and clear. While our system is being flushed out with the water, we can take that reservoir and clean that out as well. Flushing the system with water will remove the sediments that are in there, but it will not remove the rust in the scale. If you have a pretty rusted system, you may have to purchase some type of cleaning chemical at an auto parts store. Now that everything has been flushed and our residual water is coming out clean, we can start putting everything back together. Remove the hose, replace the reservoir, and connect both the lower and upper hoses to the reservoir. We can then reattach our reservoir mounting bolts. Next, we can put back together the air filter housing. We can then disconnect our tubing and close the drain plug. Make sure you do not over tighten the drain plug because it is just plastic. We also have our front shroud to replace. With regards to the drain plug, this plug goes in the engine block, which gets very hot. It is also sealing a hole in the engine where the coolant is. So we want to make sure that when we reinstall this, it's not going to leak. So during this installation of the plug, I'm going to be using Permatex's high temperature Threadlocker. This will ensure that we have a tight seal. It'll also ensure that it can withstand the temperatures of the engine block, as well as it'll make sure that it won't come unscrewed due to the vibration of the engine. Using a wire brush, I can clean off the previous compound that was put on possibly by the factory. I will be applying a consistent bead all the way around the plug, making sure that I coat the threads. When installing the plug, make sure that you start the plug by hand so you do not risk cross-threading it with it being on a ratchet, and then tighten that down with the ratchet. For this vehicle, we will be using Amsoil's low toxicity propylene glycol coolant. The manufacturer specified the use of distilled water to be mixed with the coolant. Specifically, if you mix 40% distilled water with 60% coolant, it will yield you the best freeze protection and boil over protection ratio as recommended by the manufacturer. I have a 1 gallon jug that I have calculated out and marked the 40% level in this container. If I fill the container up to the 40% line with distilled water, and I add coolant up to the top of the jug, this will give me my 60-40 ratio. That mixture can then be added to our coolant reservoir. The coolant will work its way into the system slowly. We want to continue filling it up until we reach the full cold level. After putting 3 full gallons of mixed coolant in, I am now up to the level of full cold. To help expel some of the air from the system, we can gently squeeze the radiator hoses, which will help push some of the air out of the system. At this point, we are at the full cold mark with our coolant. We want to leave the radiator cap off and start the vehicle. We want to run the engine until the thermostat opens so that coolant will begin flowing throughout the radiator and upper radiator hose. Once the upper radiator hose becomes hot, we will know that the thermostat has opened. As the engine heats up, the coolant will expand. Additionally, once that thermostat opens and we start pushing coolant around the system, there is a chance that the reservoir will overflow because we have filled it pretty full to begin with and left the cap off. Once the engine has reached operating temperature, we can turn the vehicle off and let it cool down. Once it cools down, we can add more coolant to bring it back up to the full cold mark. Run the vehicle again, let it cool down, make sure we are still full, and of course double check underneath the vehicle to make sure we do not have a leak.